Hi, I'm Derek Horn, the Application Frameworks Evangelist at Apple. In this video, I'll go into some detail about how to write native applications for the iPhone and iPod Touch. Before you dive in and start coding, it's important that you know what's available and a few things about the architecture. In many ways, it's very similar to macOS 10, but at the same time, there are differences you need to know about when designing iPhone applications. Then, I'm going to give you an overview of the application development frameworks available in the iPhone SDK, and go more in depth into the UI kit framework. That's the framework which will be at the heart of your application's user experience. The framework responsible for all the user interface, multi-touch, screen rotation, gestures, and the event system. So let's get started. Like any good frameworks overview, I'm obligated to show you an architecture diagram. At the lowest level, we've got the core OS and kernel, and this includes APIs available in libsystem, TCP networking, and POSIX calls like malloc and printf. Next, we have Foundation and Core Foundation APIs, like CF networking, NSNet services, NSString, and other base classes you'll be familiar with. Above that, we provide some rich and powerful media technologies, like Core Audio, Core Graphics, Core Animation, and OpenGL for embedded systems. Now comes the interesting part, the application frameworks, the high-level frameworks to provide a rich user experience, modern event system, and built-in controls. These are the frameworks I'll be talking more in depth about. And above that, we have the iPhone applications, like Mobile Safari, iPod, and Phone. And the good news is that I get to tell you how your applications can participate in this layer. What I want you to take away from this slide is how closely the operating system and architecture resembles the macOS 10 architecture, and that public APIs are available in all these layers. So, what is Cocoa Touch? Well, let's compare what's involved with writing applications for macOS 10 on the desktop with what it takes to write applications for the iPhone and iPod Touch. We provide really elegant application development frameworks for macOS 10. The two main frameworks are AppKit, which provides classes to manage the user experience, interact with events, and more. And Foundation provides the infrastructure for applications, networking, automatic Unicode support, file management, threading, and other low-level abstractions. Well, for starters, the Foundation framework is also available in Cocoa Touch. And now we're introducing the new framework, UI Kit, which actually has a lot in common with the latest macOS 10.5 version of AppKit. It also provides classes to manage the user experience, interact with events, and has built-in controls, but it's specifically architected with the iPhone and iPod Touch in mind. So let's dive in and take a look at the UI Kit framework. Here, I've taken a small branch of the UIKit class hierarchy to illustrate how controls, views, and windows inherit their functionality. If you're familiar with Cocoa development, you can see this has a lot in common with AppKit. All the classes inherit from their familiar NSObject base class. UI Responder adds event routing capability, as well as multi-touch. But here at the next level, UIKit does something interesting. Based on your Cocoa programming experience, you may expect a UI window to be a subclass of UI Responder, but actually, a UI window is a subclass of a UI view. Views and windows do have a lot in common, but there are some details that you need to know about. So let's take a closer look at UI window. As I mentioned, a window is a special type of view, and a typical application will create a single main window, which either takes up the full screen or is created just under the status bar. Upon creation, the window doesn't contain a content view, and it's your responsibility to create your views and add them as subviews to the window. So where you may have traditionally considered adding a window, you should instead create a new UI view and add it to the main window of your application. Throughout this presentation, I talk about UI views quite a bit, and anytime I mention APIs working with UI views, that also includes entire view hierarchies. So all UI views, including any subclass you create, are backed by core animation layers. If you're at a point where you're deciding to use a view or layers directly, a UI view is really a lightweight object on top of a core animation layer with some convenience methods. This means that without having to do any additional work, you get access to a view's transparency, you can slide it around, and you get all the added functionality and event handling views provide. If you've been using core animation on macOS 10 Leopard, you'll likely find that UI views already meet your needs for functionality and performance. Of course, core animation layers are also available to you directly for things like 3D matrix transformations, or setting an animation to automatically repeat. The UI view controller is an object that manages your user interface. It's not a view element itself, but a convenient object to load a view when asked, or notify you when it's being rotated so that you can change its view's orientation. You'll typically use a view controller to manage a view hierarchy, a screen full of views that you move in and out of the window together. The UI view controller is also able to warn you when you're running low on memory. By overriding the did receive memory warning method, you'll get an opportunity to free resources so that your application isn't forced to quit. View controllers are a very important concept within UIKit, so let's take a closer look at how one specialized controller, the UI navigation controller, works. The UI navigation controller is a very important class. I'm going to use the Contacts application as an example of how it interacts with the navigation bar. You've probably already noticed the UI navigation controller in many other built-in iPhone applications. The ideal time to consider using this interface is if you want to display a master-detail relationship, one in which you want to drill down into a hierarchy to expose more detailed information. Or use the back button on the left to get a broader view of your data. Now let's take a closer look to see how the UI navigation controller actually works. Basically, there's a top-level object, the UI navigation controller, which manages the navigation bar. When the user taps a button, or list element in this case, we want to slide in a more detailed view. We do this by calling the navigation controller's pushViewController method. The pushViewController method takes a UI view controller as input. Remember, the view controller is a convenient wrapper around a UI view itself, so the view controller is responsible for generating or loading that view by implementing the loadView method. So let's walk through the steps. First, the user taps All Contacts in the Groups view. Then, from within the view's event handling code, we call the navigation controller's pushViewController method and pass in the view controller responsible for the next view. In this case, it's the view controller for the All Contacts view. After the view controller loads its view, it automatically slides the view into position on screen as the previous view slides off. So, once again, I tap on a name within the Contacts view, my event handler gets the event and calls pushViewController, passing in the view controller for the more detailed info view. And then the navigation controller loads the view and transitions it on screen. Now I want to stop here for a second and talk about a few things that the navigation controller automatically takes care of for you. I already mentioned how it animates the transitions of new views into the main window, but it does a lot more than that. One of its primary responsibilities is to manage the navigation bar at the top of the screen. Let's start with the back button on the left side. Without having to write any code, it will create the back button and title it with the name of the previous view. It also displays the name of the current view and will create an edit button if we tell it that we have editable content. In addition to managing the navigation bar, the navigation controller actually maintains a stack of view controllers. So when the user taps the back button, it automatically pops the top view controller off the stack, transitions its corresponding view back on screen, all without running a single line of application code. Let's take a closer look and see how this works. Here, after I'm done looking at my detailed information, I tap on the back button to view all my contacts. The default behavior of the navigation controller is to call its implementation of popViewController, which pops the top view controller off the stack and asks it for its UI view. The view is prepared and slides it back into the main window, all without having to write any additional code. Again, we tap the back button, the top view controller is popped off the stack, and its view slides back into the main window. Remember, resources are tight, so as views are popped off the stack, it's a good idea to free any resources the previous view is using. So, now that we've taken a look at how the UI navigation controller works, let's take a step back and get a broad view of how a typical window is created, and a little about all the UI elements that make up the window. We're going to put all these concepts together and walk through the steps needed to create a main window and embed its subviews. At the top of the screen, we have a status bar. You can create it black or white to match the rest of your application, either programmatically or by specifying it in your plist file. Typically, an application will create its main window in one of two ways, either full screen covering the status bar or just under the status bar. So the first thing we have to do is create the main window. We do this all from code at the moment until Interface Builder is supported. If you're not familiar with creating your UI programmatically, we have some great sample code available to help you. Using the main screen bounds creates your main window under the status bar. creating a full screen window allows you to automatically have rotatable content. Like I mentioned earlier, a typical application will have a single window. UI views are then transitioned in and out of this window as needed. Now remember, a window is a subclass of a view, so it doesn't automatically contain a content view. So here, I create a navigation controller and then add its view directly into the window. Here we add two more views, a UI image view and a UI label to hold the name. As you can see, we reference images just like in Cocoa, using the image named method to load images directly from the application bundle. And here we add a table view using the grouped style. We then implement the table view's data source method to provide data and populate the table. Now we're going to add a toolbar. Toolbars appear at the bottom of the screen and let you flip between UI views, which are managed by view controllers. Conceptually, the UI toolbar is a lot like the UI navigation controller. Here are the basic steps to follow. First, we create the UI toolbar controller, which is also a subclass of a UI view controller. Now, each time we tap a toolbar item at the bottom of the screen, we want to load in a new view. So in the second line of code, I assign my view controllers to the toolbar controllers. This is an array of all the UI view controllers in my application that I want to make accessible via the toolbar. And finally, we add it as a subview of the window to make it visible and active. So this shows the general process and steps to follow when creating the user interface of your own applications. Now that we've taken a brief look at how to use UIKit to create some fundamental objects, I'd like to talk to you a little about how to interact with the system. Responding to user events is a very important part of any application, and iPhone introduces some new concepts that you need to be aware of. To respond to control events in your application, you need to call a single line of code, very similar to this one, which installs an event handler. In this code, I specify three things: the target object, self, an event handler method, switch action, and the particular event we're interested in, value changed. Now, when the toggle switch changes its value, the switch action method is called, and we print a message to the console. UIKit uses a responder chain model that is similar to Cocoa. Here, if we didn't specify a target object, the framework would actually look up the responder chain for a class which implemented the switch action method. And what's also nice is that we can install multiple handlers for a particular event. The pinching, rotation, and swipe gestures can really make interacting with your application more intuitive. You can get access to all the touches at any time and interrogate them, but UIKit has a number of methods to make it easier, and some views, like the web view, have support for pinch gestures built in. So let's take a look and see how it works. If you move your finger across the view, the system calls the touches began, touches moved, and touches ended methods, and passes in an array of touches. In this example, rather than parse all the touch events, I call a few convenience methods to return information about the touches. When I get the touch info, I check to see if it's a swipe to the right. It's that easy. We take great pride in the user experience of all our products, and UIKit makes it easier to quickly create rich user interfaces on the iPhone and iPod Touch. And standard controls are a big part of ensuring a consistent user experience. This is the UI picker. If you've ever used the alarm on your iPhone, you'll be familiar with the UI picker. It can have multiple rows and multiple columns, and each column can have a different number of rows. It just calls your method, passing you a row and column, and you return the string to display. That's it. The table view is a bit different from what you may be used to in Cocoa. For starters, a UI table view can have only one column. Now, you may find this limiting, but a nice feature of the UI table view is that you can provide a UI view, not a cell, for each row entry. And then, as you'd expect, your view's drawRect method is called when needed. This means that you can supply an entire view hierarchy for each row entry. So in some ways, it's more like the collection view than the table view. And you can create your table view in different styles, either in the more traditional indexed style or in the grouped style as we see in the settings application. UIKit also provides intuitive, easy-to-use controls and views such as switches, buttons, segment controls, text input, labels, and much more. Or you can always subclass existing controls to modify the default look and feel or build your own from scratch. So as you can see, UIKit gives you all the controls you need to develop first-class applications for the iPhone and iPod Touch. The definitive place to look for developer resources is the iPhone Developer Center, available at developer.apple.com/iPhone, where you'll find orientation videos, technical documentation, and lots of sample code. And finally, feel free to contact me at derek@apple.com with any questions you have about developing iPhone applications. The iPhone and iPod Touch are incredible devices, with a processor and operating system far more advanced than what we saw on desktop computers only a few years ago. We've created powerful frameworks and tools, and some great sample code for you to use to develop world-class mobile applications for these devices. And now I'm looking forward to seeing what kinds of amazing applications you'll create for the iPhone and iPod Touch.